Hi everyone, welcome back to another video podcast here. This time we're talking about Lecture 7, Market Structure, Perfect Competition and Monopoly. So for us, we've already in the previous lecture discussed the mechanics of creating the perfect competition and the monopoly and their profit maximizing outcomes. And we're going to move forward a little bit more in comparing and contrasting these two markets. So how do we characterize these markets? And I think this is an important point to make here between the perfectly competitive industry and that of the monopoly. So we have a few things that we can talk about. Number and size distribution of sellers. We can talk about the number and size distribution of buyers. We can talk about product differentiation, and we can talk about the conditions of entry and exit. So for us right now, our main concern, as we described, is really just talking about perfect competition and monopolies. And since these are our two anchor points, we're going to be able to then compare very well the differences between these anchor points and, as we move forward, monopolistically competitive markets and that of oligopolies. So how do we characterize, what are some of the characteristics within these individual ideas? So when we talk about the number and size distribution of sellers, we're talking about how this directly contributes to a firm's ability to set price. And this is extremely important for us. Large number of equivalent size firms diminishes a single firm from controlling price. Setting price either above or below the market rates could drop sales volume to zero or fail to maximize profits. And then we could talk about how single producer industries or few producers, which can satisfy market demand, have price flexibility. These are all the ways that we notice the number and size distribution of sellers affecting the characterization of a market. Number and size distribution of buyers is also important. Many small buyers will likely pay the same price, and for us, this is something that remains fairly standard through all of the industries we analyze. We can talk about buyers of a large proportion of an industry output can extract price concessions. Think of this, and we described a little bit in class, as a large company negotiating lower rates on premiums for healthcare or other types of things. So that's why Costco can get goods at such cheap prices, because they're buying in such large volume and they can pass those savings on through their customers. We can talk about product differentiation, and this is going to become extremely important as we talk about monopolistically competitive firms and oligopolies. So when products are undifferentiated, consumers choose solely based on price. So when you have a homogeneous product, we're only concerned about the price. It doesn't matter where your apple is from, as long as it's the cheapest apple. Differentiation is positively correlated with price control. The more differentiated the product, the more control a firm has in the price of that good. And then conditions of entry and exit are extremely important for us. Barriers to enter allow existing firms to influence output and pricing decisions. So essentially, we have these barriers, and they can come in the form of things like patents, unique ownership of resources. You could have government intervention, all of which produce some barrier to enter for competition, all of which allow a firm to essentially display some sort of market power. So the barriers to exit can prevent the reallocation of resources into different markets. Resource specialization essentially will dictate the reallocation. So depending on how specialized this firm is, they might not be able to exit an industry very quickly. So as we look to a specific industry, and that is perfect competition, we can look at all of these ideas in the context now, in the framework of this perfectly competitive industry. So firms in this industry are thought to specifically be price takers and have no market power whatsoever. We have a lot of firms here. So perfect competition refers to the structure of a market such that There are many, many, many utility maximizing buyers and profit maximizing sellers. That's extremely important, especially the idea of the profit maximizing sellers. So a good, and we always point to this, but a good example of this is farming. Because farming for us has a ton of different utility maximizing sellers, all of which are selling essentially a homogeneous good or service. There's perfect mobility of factors of production. So we can change, if we wanted to change resources or exit an industry, we can essentially do so. We can reallocate our useful resources very quickly. Buyers and sellers have perfect information about market conditions. Generally, this is true in the agricultural industry. When you're selling commodities, there's an exchange, and that exchange tells us exactly the price that people are willing to pay for that good at that time. And as we expressed, entry and exit from the industry is very easy. If I want to become a farmer, I can do so very quickly. I can grow soybeans, sell them at an exchange. If I want to change my agriculture business from soy to wheat, I can do so. So perfect competition is a very interesting anchor point for us. We very rarely see it in this extended theoretical sense, but we do get close to it in some context. So how do we understand, or how do we create then equilibrium price and quantity? So what we want to be able to do here is distinguish between the firm and distinguish between the industry. So the left panel here is going to be the industry supply and demand, where the right panel is going to show us the firm's supply and demand. And so the interaction of supply and demand in the industry, again, are going to influence what happens with the firm. So as we see prices set at P star, these prices are going to then carry over to the firm. Again, they have no type of market power here. So how do they take advantage of this in terms of profit maximization? Well, like all industries, they're going to find the point where marginal revenue is equal to marginal cost. That happens at point B. And so we have Q prime F as being the quantity that the firm's going to produce here. And so this is really good for us. How do we know, essentially, how do we know that the firm is producing at their profit maximizing level? Well, essentially, we could change. We could go to a little bit greater than QF, so to speak. So let's do QF2. And so as we go up to QF2 and we see the marginal revenue that we would obtain from QF2 being here, and if we extend this marginal cost, we see that the marginal cost that it would take to produce QF2 is greater than the marginal revenue. We know then that we shouldn't be producing at this level, and we need to produce a little bit less. And we continue to observe this until we reach that point B. So how do we know that we're making a profit? So for us, profitability is going to be total revenue minus total cost. Total revenue is just price times quantity. So the green rectangle that we're building here is exactly our total revenue. So we have this green rectangle. We then have essentially the cost to produce. So our cost to produce is going to be where we produce at up to our average total cost curve, because we know total cost is equal to Q times ATC. So we go to QF, we go up to our ATC, go over, and this rectangle that we're now producing is our cost. So we can see that the green rectangle is greater than the red rectangle, and so what's left over has to be profit. So here we're making positive profits. So how do we talk a little bit about market demand and market supply, because they came up in class a couple times. I think market demand for us is going to be something that's generally given, unless we talk about identical buyers having an individual demand. Then we could change and create a market demand. But really, when we do this, QS for us are market supply. We'll define this to be market supply. QS is going to essentially be equal to the sum of all little QFs. So if we had two firms, Q1F plus Q2F, if we had two identical firms, we could have 2 times QF. So if we have identical firms, we're able to, N is equal to number of firms. So if we have N identical firms, I should say, we could be able to do this, N times QF. So that's how we're going to be able to get our supply curve here. But notice that we're always having quantity denoted here. So what we're solving for is QS in terms of P, or QF in terms of P. So we'll always be solving for Q in terms of P in order to produce our supply curve. So how do we do this? How do we find this from an equation? So suppose we have a sum total cost curve where we have our A plus BQ plus CQ squared. Well, for us, we'll have marginal cost equaling that first derivative of total cost, so that we'll have B plus 2CQ. So now we have marginal cost. What we're going to think of is marginal cost is essentially a price to us. So we'll say that prices, or marginal cost, is going to be equal to B plus 2CQ. So now we can solve so that we have 2CQ is equal to B minus P. So that we have Q in terms of P is equal to B minus P over 2C. So now this would be our individual firm supply. So now let's say we had N individual firms, so we'd have N times QP. So we'd have N times B minus P over 2C, and that would get us essentially our market supply curve. Okay, so as we move on, we can solve a problem then in this way. So this problem 8.1 asks us, suppose that the perfectly competitive industry comprises 1,000 identical firms. Suppose further that the market demand and supply functions are given. So we want to calculate equilibrium market price and quantity. Then, given our answer to A, how much output will be produced by each firm in the industry. And then suppose that one of the firms in the industry goes out of business, will be the effect of the equilibrium market price and quantity. So let's start tackling this. So 8.1a says give the equilibrium market price and quantity. So we know equilibrium condition is going to be QD is equal to QS. So we can start writing that out. So we have 170 million minus 10 million P is equal to 70 million plus 15 million P. So we could simplify this down, and so we're going to end up with a P star of 4. Good. So we have our price. How can we solve for quantity? Well, we can plug back into either demand or supply. We've imposed this condition at equilibrium, so we can do this, and I'm just going to plug it right back into our demand curve. So we have QD at P star is going to be 170 million minus 10 million times 4, so that we are going to get 130 million. Great. So this is our Q star in the market. So now we have P star and Q star. So part B says, given your answer to part A, how much out will be produced by each firm in the industry? Well, we have the market being Q star. We have N identical firms. So we can find out what Q of little f is going to be. And this is a really good way to think about this relationship. We can rearrange this to also look like this, that the industry equilibrium divided by the individual firm's contribution, as long as they're identical, is going to be equal to N, the number of firms. So for us, what we want to do is start plugging in values. So we have 130 million divided by then 1,000, so that the quantity that each firm essentially produces is going to be equal to 130,000. Good, so that's part B. C then says, suppose that one of the firms in the industry goes out of business. What will be the effect in the market equilibrium, the price and quantity in the market equilibrium? So intuitively, what we would expect is that since there's many buyers and sellers, that one single buyer leaving one single seller leaving the market is not going to reflect any difference in the equilibrium price and quantity. And so we can set this up. And I think one way to do this is you could find the individual firm's supply curve very quickly. So again, we could look at the supply curve, QSP, the industry supply curve, and divide it through by 1,000. That'll give us the give us the firm's supply curve. And when we do that, we get 70,000 plus 15,000 P. So now we could take the existing industry supply, 170 million, sorry, not 170 million. We're going to do 70 million. So we have 70 million plus 15 million P. And then we're going to subtract out that individual firm. So we have 70,000 minus 15,000 P. So now we're going to set our new supply curve. So not 1,000 firms, but 999 firms equal to our market demand, so that we have 170 million minus 10 million. And that's going to be equal to our new supply. So 69,930,000 plus 14,985,000 P. And so that we can solve for P, and now we have a new market equilibrium, 4.0052. So we can see that prices haven't changed at all. So prices when we had 1,000 firms were 4. Prices when we have 999 firms still are 4. Exactly what we expected to happen. So as we continue on, we can look a little bit about how we want to maximize profits. We know that already intuitively we want to set marginal revenue equal to marginal cost. So mathematically, the way that we invoke this is taking the first derivative of our profit function. And in many ways, in order for us to do this, we need to build our profit function. So what we do is build it by using our two components, total revenue and total cost. And so by looking at the largest difference between the two, we're able to essentially find our profit maximization. The tool that we employ here is our first derivative, so we set that equal to 0. And really the implication is that we're finding where marginal revenue is equal to marginal cost. But in terms of our perfectly competitive industry, we know that marginal revenue is going to be equal to price, and it's going to be fixed. It's something that's set by the industry. The firm just observes P naught. So all we're doing here in order to profit maximize is looking at the condition P is equal to marginal cost. So firms must choose a quantity. That's what we're solving for. We're solving for a quantity which equates prices to marginal cost. And so we already saw this picture before, and now we have a little bit better understanding about why a firm is choosing a specific quantity and not necessarily choosing a price. And this is going to be very different for a firm who's a monopolist and who's going to be able to set price themselves. So mathematically, and again, we talked through this a little bit before, but mathematically and then looking at it graphically, we're able to determine the area at which we can see profits, revenues, and losses. And so it should be noted that the cost curves here are going to always include implicit cost of production, unless it's otherwise stated. But we haven't encountered any type of problem that's going to ask anything other than costs, including implicit costs. So we have another problem, 8.2. And so 8.2 gives us this total cost equation. So right away, I'm just going to notice that total cost is equal to 1,000 plus 2Q plus 0.01 Q squared. And it says the firm operates in a perfectly competitive industry, and I think that's good. So we know we're looking for a perfectly competitive outcome. And the other trigger or key word here to determine is that prices are set, or they can sell its product at a determined price of $10. So we know that P star, or P sub naught, has to be equal to 10. That's very telling for us. So to maximize total profits, what should the firm's monthly output level be, and how much economic profit will the firm earn each month? So instead of building our profit function, which we could absolutely do, we could do this. We could say profit is equal to P times Q. So we have 10 times Q minus 1,000 plus 2Q plus 0.01 Q squared, which we could then take our first derivative, set equal to 0. What we could do also is recognize the condition that falls out of this, and that is that P sub naught is equal to marginal cost. So we know what P sub naught is, and we have our total cost, so we're able to quickly find what marginal cost is. So marginal cost, if you recall, is the first derivative of total cost with respect to Q, so that we would get 2 plus 0.02 Q. So we can easily equate these. So we have 10 is equal to 2 plus 0.02 Q, so that we have 8 is equal to 0.02 Q, so that we solve for a Q, and we are going to get a Q of 400. Good. So now we have a Q of 400. What we're now able to do is take this value, plug it back into our profit equation, because we already given price. So let's take profit, evaluated at P star and Q star, which is going to be equal to 400 times 10 minus 1,000 plus 2 times 2 times 400 plus 0.01 400 squared. And so when we have the profit, and so when we do our math, we crunch this on the calculator, we should get a profit of 600. Great. So now we have our two answers. We have Q star is going to be equal to 400, and we have profit will be 600 in this market. So moving on then, what we see is we can talk about the short run and the long run in a slightly different context. So in the short run, we observed here that profit was positive. That profit, this firm was essentially making $600. So what does that mean though in the long run? In the long run, we can understand that since there's easy entry and exit, firms are going to enter if they observe positive profits in the industry. So profits will attract firms into the industry, increasing market supply and lowering prices. Essentially, we're eroding profits. Whereas losses, if firms are experiencing losses in the short run, losses will repel firms from the industry, thus decreasing market supply and raising prices. Essentially, we'll be trying to erode losses here. So what we observe here is that changes will not be instantaneous, but firms will operate in a short run until all of their resources can be reallocated. And so essentially what we're doing here is showing exactly how the slow process takes into effect. So what we have here is supply essentially shifting to the right. So we have market supply, so QS is rising. And so why is this rising? Well, it's because firms had to be observing positive profit to begin with. But what we see happening is since supply curve is rising, prices have to be falling. And if prices are falling, we observe that the quantity that the firm produces also falls. And we're going to continue to fall until we don't want to enter or exit the industry anymore. And so in the long run, what we're going to observe is that we're going to get to this point right here. We're going to get to the point where we find the minimum of that average total cost. That's going to be our long run output. We also call that a break-even point. So firms continue to enter and exit until there's no incentive to enter or exit the industry. So like we just described, this is referred to as the break-even point. Another way to think about this break-even point is that we can look at total revenue has to be equal to total cost. And another way to write this is that P times Q has to be equal to Q times ATC. So that P has to be equal to ATC. This is our break-even condition. So, like we described earlier, this process needn't be smooth. Uncertainty and incomplete information can lead to miscalculations by firms. So there's firms that could remain in the industry that shouldn't necessarily be in the industry. Or there could be firms that are exiting too soon. Too many firms, though, could potentially enter into an industry, and that's something that we could absolutely see. Everyone has the same idea at the same time, dropping prices below a threshold that they wanted to, and eventually firms would drop out and recognize this over time. So what we want to know is, suppose this actually occurs, and what we're seeing is a loss in the short run. Does a firm continue producing? And I think this is a really important point. So here, what we're trying to observe, or the question kind of we're asking here, is do we shut down? And so we just observed a long run phenomenon of our break-even point. Here what we're observing, or we're trying to look at, is should we produce even in the short run? So economic losses and shutdown, I think, is important as well. So managers are making decisions when facing an economic loss. And so they have to decide between maybe a few different outcomes. First, they have to think, should I continue producing at this economic loss, hoping that prices will eventually rebound, right? Or the other side is, do I just shut down operations completely? You might not always have exactly these two options, or there might be some spectrum of options in between. Do I gradually shut down? Do I continue producing at maybe even a higher rate for whatever reason? But shutting down is specifically a short-run phenomenon where exiting an industry is absolutely a long-run decision. Again, we want to make sure that we understand this, because shutting down in the short run assumes that we have at least one resource which is fixed. Think of this as your storefront, the lease that you have. Reallocating all of our resources then can't be completed. So we can't actually exit the industry. All we're doing is closing down the storefront. Restaurants do this all the time. Restaurants decide or understand that essentially they know that some days of the week are going to be more profitable than others. They understand that Mondays and sometimes Tuesdays are not a night that people go out to dinner. And so they close their doors. And so they understand why are essentially they closing their doors. Prices aren't changing on the menu at all. But they realize that what's happening is that they're not able to cover the variable costs of production, is that they're not able to essentially, they know that the quantity of dishes created is not going to be able to pay for the chefs, the waitresses, the bartender, the hostess, the manager to come in. And so they shut their doors for the day. And so we can understand a little bit what that is. In order to do that, we want to break down total cost again. So we recall that average total cost is equal to average fixed cost plus average variable cost. And so we realize that we can't really affect this average fixed cost. That's something that we can't change. But firms absolutely have the ability to adjust their average variable cost depending on how much or how little that they produce. So what we can think here is, let's just look at this average variable cost then. If we can cover our average variable cost, and hopefully we can cover this average variable cost and pay off some of our fixed costs, even though we're facing a loss, we're still in good shape. That's fine for us. We like this. But if we cannot essentially cover any of our average variable cost, then we have to just shut our doors. We'll try again tomorrow. That's the idea. And eventually, over time, if this persists, in the long run, say, we'll then be able to exit the industry. But we want to find the shutdown point first. And so before we do that, here's a graphical interpretation of what we could potentially be looking at. So what we see here is firms continuing to enter. So they go from, they continue entering the industry. And as a result, prices keep going down. And we go down to this PSD, this price of a shutdown point. And what we realize is that it occurs right at this minimum of AVC. And so that's going to be a very, very important point for us, is that minimum of AVC is going to reflect the price needed to stay open, whereas the minimum ATC is going to reflect that long-run equilibrium. So there's two qualifications for shutting down that can be made. Firms will only shut down if they believe that prices will remain below average variable cost for an extended period of time. Some production processes are not easily stopped and started. We talked a little bit about those in class. Competitive firms may not be shutting their doors either. So you might stay open in spite of not being able to cover your variable costs solely to compete. The other kind of caveat here is firms will shut down if they perceive their time frame to be short run. Again, this is very important, and it's going to be different by each firm and by each industry. So can the firm contribute to eliminating fixed cost? If that is true, if they believe they can eliminate even a portion of fixed cost, then we understand that the firm is making shutdown decisions. Okay, so let's solve a problem here. So we have problem 8.5. And it says a perfectly competitive firm faces the following total variable cost function. So we have total variable cost is equal to 150Q minus 20Q squared plus Q cubed, where Q is our quantity. Below what price should the firm shut down its operations? Well, again, we have this condition. We essentially want to be able to find the price that's less than that minimum average variable cost. So in order to find this condition, let's first create average variable cost. So we know that total variable cost divided by Q is equal to average variable cost, so that we get 150 minus 20Q plus Q squared. Let's now find our first order condition. So now let's look for DAVC DQ, so that we get negative 20 plus 2Q, so that we now have equaling 0. So essentially, we can solve for this. 2Q is equal to 20, Q is equal to 10. So now we have the quantity that minimizes average variable cost. Now, in order to find what that price would have to be, or what is that actual average variable cost, let's plug that into our equation. So let's take average variable cost and evaluate it at Q star, so that we have 150 minus 20 times 10 plus 10 squared. So we have 150 minus 200 plus 100. So then when we solve for this, we get 50. So if we were drawing this picture, and we have something like this, we have average variable cost, and we found the minimum to be 10, we go over here and find that our price is 50. So any price below 50 is going to induce our shutting down. So we would just finish this answer as P has to be less than 50. That is our shutdown point. Good. So we can continue on now. Do another problem. Another problem says here in 8.6, this is a long one. So now what we have is Hale and Hardy Limited is a small distributor of B&O food stores and a highly competitive healthcare products industry. The market determined price of a 100-tablet vial of HH's most successful product, papaya extract, is $10. HH's total cost, TC, is given by here. So we have TC is equal to 100 plus 2Q plus 0.01 Q squared. And essentially we have prices are going to be equal to 10. What is the firm's profit maximizing level of output? Well, we know that they are perfectly competitive. We're told so. So we can immediately start in this problem by setting our conditions. P naught is equal to marginal cost. So now we can start plugging in some values. So we have, let's see if we can get some of this back on the screen. Okay, so we are going to do is include 10 as our price that we were given, and marginal cost. We know that marginal cost is going to be that first derivative of our total cost function with respect to Q. So I'm going to solve this as being 2 plus 0.02 Q. So now we can go through this a little bit more, and we can solve in order to get 8 is equal to 0.02 Q. So again, we find a Q that is going to be equal to 400 for us. So then what we want to know is what is the firm's profit maximizing level of output. This is good for us. What we want to know is also what is the firm's profit at the profit maximizing level output. So what we could do here is plug our values back in. So we know that profit is going to be 10 times 400. That's going to be minus 100 plus 2 times 400 plus 0.01 400 squared, so that we get a profit of 1,500. Good. So we have a positive profit. We have a positive economic profit here. How do we know that we are in the short versus the long run? Well, I would say really right off the bat, since it's greater than 0, we know that we're in the short run. We're going to expect firms to enter here and erode some of our positive economic profit. That would be my little explanation to the end of A. So then B asks, at P is equal to 10, what is HH's break-even output level? Again, if we're talking about any break-even level in the short run, what I would say is that we're looking for, again, the point where total revenue is equal to total cost. So if we think about this and we look at our total revenue function, we know total revenue is going to be 10 times Q, where we know total cost is this 100 plus 2Q plus 0.01 Q squared. So we're looking for this equality in some way. And so what we can do is solve for Q here then. And what we'll be able to do is through our quadratic formula, solve for 2 Q's. And so really what we're expecting or what we're thinking is that we probably have a situation that looks something like this, is that we have a Q that looks like this. And so what we're now going to have is 2 different break-even points for us in the short run. And so as we go through this and we set up our quadratic formula, so we have 0 is equal to 0.01 Q squared, and we have minus 8Q plus 100. And we can start plugging things into our formula, or if you have a calculator here, you can plug them right back into the calculator. So we know the formula is the opposite of B, plus and minus the square root of B squared minus 4AC. That is all over 2A. And so we now have A, B, and C. So we can plug those in, and when we solve down, what you should get is these 2 Q's. So Q1, we're just going to say is 787.3, and Q2 is going to be 12.7. So these are going to be our 2 break-even quantities. Part C then says, what is HH's long-run break-even price and output level? So now what we're given is not at a specific price of 10, but now what is the price that's going to get us to this break even? Now what we're doing in the long run is looking for this minimum of our ATC and what the price associated with that is. So now we can start setting this up. What we need to do is find ATC. So our average total cost is going to be 100 divided by Q plus 2 plus 0.01 Q. So we can take our first derivative, ATC divided by Q, so we have negative 100 over q squared plus 0.01. And we're going to set that equal to 0. And then we can rearrange so that we have essentially 100 over q squared is equal to 0.01. So 100 divided by 0.01 is equal to q squared. So we can take the square root of both sides. And so what we now have is a q, which is going to be equal to 100. Great. So we now have a q equal to 100. This is going to be, essentially, this is the minimum ATC, that quantity. So the quantity that minimizes ATC. So now we can solve for our price. So what we're going to do is evaluate ATC at 100, so that we have 100 divided by 100 plus 2 plus 0.01 times 100. So as we solve this out, we're going to get a price which is equal to 4. So now we have the price and the quantity, essentially, that minimizes our ATC. So this is 4, this is 100. Part D then asks, what is the shutdown price and output level? And so that's the first part, and we could essentially take advantage of what we know here. So in part D, what we're doing is looking at, we need the price that's less than the minimum average variable cost. So let's construct average variable cost. So we know that total cost minus total fixed cost is equal to total variable cost. So our fixed cost, which isn't affected by Q, is just 100 here. So we're going to subtract this out to get total variable cost is equal to 2Q plus 0.01 Q squared. Average variable cost is then going to be 2 plus 0.01 Q. What we notice is that this is linear. So if I look at this, that we have the equation of a line, so that our intercept term is going to be 2. It's positively sloped with a slope of 0.01. So we have prices and quantity on these axes. So technically, there is no minimum of a linear function. If I were to take the derivative and set it equal to 0, it would be nonsensical. So what we do, though, is realize that we're constrained in this positive quadrant. So Q cannot be anything less than 0. And so if that's the case, and we're constrained by this vertical axis, the minimum then is going to be right here at 2. So that we get that prices less than 2 are going to shut down this firm. Great. And so we have the solutions here as you guys work through this again yourself. So what we could do now is look to the other side of the spectrum. We could look at this monopolist. The monopolist for us is going to be a single producer. They're downward sloping demand curve, and this is due to the firm being a price maker. And this is, I think, an extremely important idea, is that the firm now faces a downward sloping demand curve and is able to choose price in some way or has some pricing power. So there's a very high barrier to entry, and we can talk about why that is. There's a few different reasons. There could be resource rights. These are firms that are owning a very specific resource, or that resource which is unique. We talked about De Beers Diamond Company as being one that's very important there. We talked about Alcoa, Alcoa being a firm that owned bauxite mines to the point at which they were considered a monopolist. You can create patents. Pharmaceutical industry relies on these patents, as well as the technology industry, to kind of be that unique provider of a specific resource. You could have unique managerial talent. Now, this one is often hard to understand and pinpoint, but there are people like Elon Musk who clearly have some talent that's unique. And you could think then maybe Tesla Motors or the other industries that he runs are in this very unique monopolistic perspective. You could also have economies of scale, And with this economies of scale, we're tending to think that this is more of a natural monopoly, that the monopoly in this industry arises because we should only have one firm producing, because as they produce more, the average total cost is going to decrease. You also have the government franchises. Essentially, these are monopolies that are allowed to exist under the DOJ, the Department of Justice, and the government for a variety of reasons. Okay, so we talked through each one of these a little bit, but again, I think that resource rights are extremely important. Patent rights are extremely important. Same as government franchise. But I think what really becomes important here, and that we don't really necessarily take the time to look at, maybe in another economics course we would, but that is the idea that you need to be able to have the creation and enforcement of private property laws. This idea is instrumental in understanding why firms are striving to be monopolists. If there was no enforcement of these private property laws, firms would not necessarily be incentivized to take on maybe large costs, especially in an industry like the pharmaceutical industry. They rely specifically on the enforcement of product or patent infringement, so that they know they're guaranteed some profit in the long run. So as we move on from these ideas and look graphically at what the monopolist is facing, we see that in the short run, the profit maximizing price and output is constructed in a fairly similar way to what we saw in the perfectly competitive market. So what we understand is that a firm is always seeking the point where marginal revenue is equal to marginal cost. And essentially that happens here. So we see this. So we see them finding this point. And so what that does mathematically, again, what we're looking for is where marginal revenue is equal to marginal cost. This is our mathematical point. We find QM. Now we take QM and plug it back into our demand curve. That's what's going to get us our prices. So once we've solved for a QM, in order to show that we can set our own price, we have to determine what an individual or what individuals are going to pay for that. So what we do is we're facing a demand curve. Let's take the quantity that we decide to produce and plug it into the demand curve. And what happens is we have price popping out. So now we're able to see what price we're essentially able to set in this industry. And in this specific example, we find that this firm is earning positive economic profits. So again, to recap, we always want to find where marginal cost is equal to marginal revenue. Selling price is determined through the demand curve. That's extremely important. So let's just, for example, say, suppose barriers to entry are extremely low. Firms entering the industry would then experience a more elastic demand curve until enough firms entered, which then creates a perfectly elastic demand curve seen by perfect competition. So if we were to essentially look at this, and we'll just do a few of these, is that if we start with some demand curve for a monopolist and some supply curve, so what they're going to do is be able to charge, given a marginal revenue curve, they're going to find this point. So we have demand, marginal revenue, marginal cost, and then they go up to the demand curve. So this is the price in the market, and this is the quantity that they're going to sell. The idea is, well, let's essentially be able to change demand. What would happen if we were to allow people in? And so demand would get flatter. And then let's say we were allowed to have more people. Well, demand would get even flatter. And let's say that we were able to let as many firms as we want in. Well, then demand would get very flat. And we would see a perfectly competitive sense. So when we analyze the market industries between perfectly competitive firms and monopolists, this is what we're looking at. We're looking at the demand curve becoming more elastic as we move from a monopoly to an oligopoly, and as we move from an oligopoly to monopolistically competitive, to then become perfectly elastic as we move from monopolistically competitive firms to that of perfectly competitive firms. Okay, so how would we solve a problem here? So this problem, 8.7, I think is a good one because I think it's a very basic one that explains just the process that we want. So in 8.7, what we have here is two equations. We have a total cost equation. So total cost is 500 plus 20Q squared. And then we have pricing. Price, or our demand curve, is going to be equal to 400 minus 20Q. We want to solve for the profit maximizing price and quantity in this industry. So like we said before, we're always searching for that where marginal revenue is equal to marginal cost. Let's set up a profit equation though. So we have profit is equal to Q times, we have price, so it'll be 400 minus 20Q. And we're going to subtract out of that our total cost. So we have 500 plus 20Q squared. So let's find our first derivative with respect to quantity. So that we have 400 minus 40Q minus 40Q is equal to then 0. So then we solve this. So we have 400 is equal to 80Q. So then we solve this to find that Q is equal to 5. Great. So now we have the profit maximizing level of quantity for this firm. And so again, if we're drawing this picture out, and so we have price and quantity on this axis, we have demand, we have a marginal cost curve, we have a marginal revenue curve. What we've just done is equated marginal cost and marginal revenue and solved for 5. We now need to take 5 and plug it into the demand equation to find what this price is going to be. So we evaluate demand at our quantity of 5. So we have P is equal to 400 minus 20 times 5. So that prices in this market, P star, is going to be equal to 300. Good. And we can complete our graph. And so that's a very basic way to solve this problem, but it gets to the heart and the crux of every issue, is that firms are finding where marginal revenue is equal to marginal cost. That's extremely important for them. So profits essentially will remain competitive for ourselves because there's no one essentially coming and competing away our profits. So firms are going to try as hard as possible to be essentially that monopolist. They're going to do what we call rent seeking. They're going to try in any way possible to hit one of those characteristics that we saw in the beginning of the monopoly example, and that is looking for unique ownership of resources, creating those patents, finding unique managers, trying to make sure that they can hold on to profits. So let's look at problem 8.8. So 8.8 says, suppose that an industry is dominated by a single producer, that the demand for its product is this. So we have QD is equal to 3,000 minus 60P. Suppose further that we have a total cost function, so that total cost is equal to 100 plus 5Q plus 1 over 480 Q squared. Part A asks, what is the monopolist profit maximizing price and output? Well, we know how to do this. I would say let's construct our profit function. The first thing that I would do, though, is recognize that we want to change our demand curve. We want to make inverse demand. Right now, we have demand in a form that's non-graphable. We want to be able to graph this function. So let's solve for P in terms of Q so that all we have in terms, so we want profit just in terms of Q. So if that's true, then we're going to have to look at P in terms of Q times Q minus total cost in terms of Q. So let's solve for P in terms of Q. So we have Q minus 3,000 is equal to negative 60P, so that we can divide through. So we have Q minus 3,000 divided by negative 60 is equal to P. So we have 3,000 divided by 60, so we should have 50 minus 1 over 60Q is equal to P. So now that we have profit in the way that we need, that we have demand in the way that we need, we can start plugging into our profit equation. So here we have profit at Q is going to be equal to Q times 50 minus 1 over 60Q minus now our total cost function, which is 100 plus 5Q plus 1 over 480Q squared. So now I'm going to take our first derivative with respect to Q. So that I get 50 minus 2 over 60Q minus 5 minus 2 over 480Q. It's going to be equal to 0. So now what we could do is solve down so that we get Q in this instance is going to be equal to 1200. Good, so we've solved now for Q star. What we could do is take our Q star, plug it back into our demand equation. So what we're going to do is look at P evaluated at Q star, which is going to be 50 minus 1 over 60 times Q star, which is 50 minus 1 over 60 times 1200. So that we have P star for us is essentially going to be equal to 30. Great. So we now have the profit maximizing quantity and price for this monopolist. So what we want to know then is what is our firm's economic profit? And so we have our profit equation. Let's plug in for the values that we know. We know what P and Q are going to be. So we have profit is going to be equal to 30 times 1200. And we're going to subtract that from our total cost. So 100 plus 5 times 1200 plus 1 over 480 times 1200 squared. So that profit for us is going to be 26,900 after we crunch that down. Good, and so we, as we expected, positive economic profit, but that's not always the case. Monopolists might be making losses, so we don't always make a positive economic profit. Okay, so moving on then. What we want to be able to do is talk a little bit about monopolies and then the price elasticity of demand. From your principles classes, you might remember that a monopolist is essentially pricing on the elastic portion of the demand curve. Well, we can prove why that is. And so what we're going to do is first take the derivative of our profit function with respect to Q and set equal to 0. And then what we could also do is include our inverse demand curve in this condition. So we're going to plug in essentially our inverse demand function. So when we do that, we're going to get P plus Q times dP over dQ minus marginal cost is equal to 0. So we've essentially just replaced this component. What we can do now is take P to the other side with marginal cost. And so when we do that, we can then divide through by P, and nothing changes once we divide through by P. But what we get is something really fantastic, and that is this left-hand side should look really familiar to us. It's the negative of the inverse price elasticity. But the right-hand side is very simple. It's just price minus marginal cost divided by price. Very simple condition that we just described here. And so what we essentially observe is that firms are going to be able to price over marginal cost in some way. That's the beauty of their market power. So how can we measure this? And so what we say is that this is called the Lerner index. So this Lerner index is a very simple formula. And so how do we interpret this? We know that the prices are going to have to be at least greater than marginal cost, that the right-hand side has to be positive or cannot be, essentially is non-negative. If that's true, then what we realize is that the left-hand side has to then be, because of this negative sign, this price elasticity also has to be negative. So if our right-hand side is positive, the left-hand side is required to be positive. So what do we say? What will then require this? We know that then this is true, that price elasticity has to be, in this sense, has to be essentially greater than -1, between negative infinity. So we can say that essentially the way that we've constructed this, that prices above marginal cost have to be very elastic in some way. So that's how we know we're pricing on the elastic portion of the demand curve. But with this Lerner index, what we could do is understand how strong is this monopoly? How much pricing power do they actually have? So the higher this index, the more power that we see this firm has to price. So since it's the negative inverse of price elasticity of demand, we're using it in a slightly different way, and that is to measure monopoly power. So it's going to take on values between 0 and 1 for us. So the greater the distance between price and marginal cost, the greater the Lerner index is, and thus the more monopoly power this firm has. So if we think about this, and we kind of have a clue here, we know that it's going to take on these values between 0 and 1. What is the Lerner index of a perfectly competitive firm? We know that in the perfect competition, price is going to be equal to marginal cost. And if that's true, then our Lerner index is going to be equal to 0. So perfectly competitive firms have a Lerner index of 0, and that fits exactly with what we believe. So now we have problem 8.10. So we have a market demand for a firm, that is is equal to 10. So we have a perfectly competitive firm. So for problem 8.10, we have price is equal to 10, and we have a total cost function 100 plus 6q plus q squared. We want to calculate the Lerner index. We know that's going to be price minus marginal cost over price. This is going to be our Lerner index. So we need to find these values. We know what price is, so let's just plug in price at marginal cost. So let's solve for marginal cost, and that's going to be 6 plus 2q. So when we plug our value in, what we realize is that we essentially need a q here. So in order to find this q, what we can do is set price equal to marginal cost. So let's look at 10 is equal to 6 plus 2q. So we have 4 is equal to 2q, so that we have 2 is equal to q. So now we know that this q star, this is the profit maximizing level of quantity, q star. So if that's true, then let's plug back into marginal cost. So marginal cost evaluated at q star is going to be equal to 6 plus 2 times 2, which gives us 10. So when we calculate this Lerner index, we see that we have 10 minus 10 over 10, which is 0. Exactly what we expected for a perfectly competitive firm. So now we have problem 8.11. So now we have a demand curve. So we have prices are going to be equal to 10 minus q, so that we have total cost is equal to 100 plus 6q plus q squared. So now we want to calculate the value of the Lerner index for this firm. So again, we're going to have to do is actually find the profit maximizing level, price, and quantity that this firm would find. So let's set up our profit equation. So profit is going to be equal to q times 10 minus q minus 100 plus 6q plus q squared, so that we have d pi dq equaling 0, so that we have 10 minus 2q minus 6 minus 2q, so that we can solve now, so that we have 4 is equal to 4q, so that q star is equal to 1. So now let's take q star and plug it into price. So let's look at our price evaluated at our profit maximizing level of quantity. Is going to be equal to 10 minus 1, which is equal to 9. So now we have essentially our price. So let's find our marginal cost. So marginal cost is going to be equal to 6 plus 2q. So let's look at our marginal cost evaluated at our profit maximizing level of output. So 6 plus 2 times 1. So marginal cost is going to be equal to 8. So now our Lerner index is going to be equal to price minus marginal cost over price. So we have 9 minus 8 over 9. which gives us 1/9, which is equal to 11.1%. So essentially this Lerner index says is that what we could do is we could price over marginal cost by 11.1%. This isn't necessarily a great monopoly. This is not huge monopoly power, but it's not bad. We clearly have some market power in this instance. And I just want to make a note here on this slide that the solution in the book is incorrect. So the solution in the book reads something different. This needs to be 1/9, not 1/8. Okay, so how can we analyze or evaluate both of these firms, or both of these industries together? So we're looking at the differences and similarities between monopolies and perfectly competitive firms and essentially where they're producing. We realize that both firms are always going to choose to produce where marginal revenue is equal to marginal cost. So we're always looking at the industry demand curve and the marginal cost curve for the perfectly competitive firms. This is what sometimes we call the socially optimal level of output. So this will be socially optimal. And clearly what we realize is that a monopolist is not socially optimal. What we find out is that perfectly competitive firms are going to choose larger quantities, which are going to be on the inelastic portion of the demand curve, where monopolists choose smaller quantities that are going to be on the elastic portion of the demand curve. This allows monopolists to price higher, whereas perfectly competitive firms have to price lower. Prices, we know, are set in the perfectly competitive industry, whereas with a monopolist, we find that it's where essentially our quantity is going to intersect our demand. Prices will fluctuate for perfectly competitive firms as the industry sees entrants erode profits or exiters reducing losses, but that's not necessarily going to be the case for the monopolist. So given these ideas, and this is a very maybe convoluted graphic here, but what we're doing is analyzing a few different points. And this left panel, I think, is the best, is that what we find is that this is the socially optimal or perfectly competitive. So we have PC and QPC, right? So this is our perfectly competitive output, and it's exactly where marginal cost is equal to demand. And we realize that it's different than a monopolist, whereas the monopolist is producing at QM, pricing at PM. And it's exactly what we would expect. So visually, this is what we're seeing here. So what we notice then is that monopolists have to be less efficient than perfectly competitive firms. And that's true, because if we go back to our picture, what we realize is that what is going on here is that essentially this monopolist is choosing a quantity that's not essentially minimizing their average total cost. So they cannot be efficient here. What we'll find out is that as firms essentially enter the industry, which forces supply to this way, perfectly competitive finds that minimum average total cost. That's how we know it's efficient, is that we're producing in the long run at that average total cost, whereas the monopolist doesn't observe this. So we have some inefficiency that's occurring. What we like to believe then is that monopolists are misallocating society's productive resources in the sense that not enough of the products is being produced. Something else is using those resources. Society wants more, but someone else is using those resources. What could happen is that the government observes this. They observe that there's a monopolist in the industry. Maybe this monopolist is in the industry because they have some sort of economies of scale advantage over everyone else. And they realize that the socially optimal level of output is going to be larger than what the monopoly is going to produce. The government then could step in. And now what happens is that they have to regulate prices. And so from one side, the monopolist says, no, we need monopoly profits. The other side says, listen, no, we want prices lower, and we would rather the monopolist to make zero economic profit at all. And so the politicians now step in and say, well, I'm not exactly sure where we should have prices, but I know that we shouldn't have them at the monopoly level. And I know to incentivize firms, we can't drop prices down at the perfectly competitive level. So what we're going to see is firms are going to be allowed to charge what we call a fair market price. So what we could do is analyze the effects of the inefficiency. So we could look at these welfare effects, we call them. So we're concerned primarily with the idea of consumer and producer surplus. And so when we think of this, and again, this for some of you, this is kind of knocking the rust off of your principles class. For others, this might be a little bit more than that, but consumer surplus is the difference in what a consumer was willing to pay and the price that they actually pay for a good or service. This is the area that is concentrated below the demand curve and above the market price. It's also constrained by the amount of quantity that's produced by the firm. The producer's surplus, then, is the difference in what a producer receives and the minimal price the producer was willing to accept. Again, I think that's a very important idea. Essentially what we have is that we now are concentrated on the area above marginal cost, or their supply curve, but below the market price. Again, we're constrained by Q. And this constraint of Q, the amount that we produce at our profit maximizing level, is important when we analyze the welfare effects of a perfectly competitive firm versus that of a monopoly. So when we look at the welfare effects, what we could do is first analyze the benefits to a consumer. So what we do here is look at, so what we can look at essentially the benefits that consumers receive. This entire area is the consumer benefit. And what we think about is it's just reflecting the area under the demand curve, again constrained by what we produce, Q star. But then we realize that there's going to be essentially a cost to the consumers. So the consumers, essentially, they pay for just some portion of their goods. So they're only left with this area right here. And so this is a little bit different than when we look at the firms. And the firm is then, they are going to realize that they are going to receive this entire amount from producing, right? P times Q, that's their sales, so to speak. But when we look at this, what we want to do is kind of eliminate some of the producer's costs, because we know that everything that they receive is not going to be profit. We have to indicate that there's some costs available. And so what we find out is that when we erase some of this, then, is that firms are essentially only going to be obtaining their area above their cost, which is right here, right? So we now have consumer surplus and producer surplus, which is built out of the benefits and costs to producers, and exactly what we described here. So in order to find these areas, we know that the area of AEP is just 1/2 base times height. So in this example, consumer surplus is 1/2 times the length of the legs of the triangle. So A minus P star times Q star minus the origin, 0, right? And producer surplus, very similar. So we have 1/2, and then we have the difference, the length of the legs. So we have P star minus B times Q star minus 0. So both of these are going to essentially give us the area of consumer and producer surplus. So when we talk about welfare effects and we're comparing the difference, we realize that under perfect competition, we're always maximizing welfare for consumers and producers. We're always. And I think that's really important. This is the max that we're finding. Whereas in a monopoly, we see that consumers are made worse off while producers are better off. So there's a trade-off going on, that we're transferring welfare from consumers to producers. What we find under the perfectly competitive instance is that the marginal benefit derived from consuming is equal to the marginal cost society for producing. And so we're exactly efficient there. But what happens under the monopoly is that they have the ability to charge higher prices, and that erodes the welfare. Perfect competition is essentially ideal. It's the ideal market structure because we observe the capture of all social benefits. Monopoly industries are not ideal, as they are creating deadweight loss. And that's something that we need to evaluate and understand here. So we have the monopolist. I'm going to highlight here the original consumer and producer surplus. So that's the original consumer surplus under perfectly competitive circumstances. And this is the original producer surplus under perfectly competitive circumstances. And so what we're going to do now is highlight essentially the reduction of consumers' welfare due to the restriction in monopoly. So this is the reduction in welfare from the consumer's point of view, whereas this is then the reduction from the producer's point of view. So we have this area right here. So we essentially have gotten rid of this entire triangle, and this entire triangle is then deadweight loss. And so we now know how to calculate this area, this deadweight loss. But what we see is that the consumers, we have now what we're going to do is understand that producers are going to get this little green area back. So producers receive, this is the income transfer that's going to firms. And so now, if we were to calculate essentially our producer surplus, it would be this red shape right here, whereas consumer surplus would look something like this triangle. It's much more reduced. And so we went through some problems in class and through our homework and how to solve this. And so let's do one right here. So we realize that we have a monopolist, and we see that Q is equal to 22 minus P over 5, where total cost is equal to 100 minus 10Q plus Q squared. So A says find the profit maximizing price and output for this firm. At this price quantity combination, how much is consumer surplus? Okay, so we're looking at from the monopolist point of view. So let's start setting up profit. Profit is going to be, well, we realize that we need P in terms of Q times Q minus total cost in terms of Q. So let's rearrange this so that we have P over 5 is equal to 22 minus Q, so that we have P is equal to 22 times 5 minus 5Q, so that we have P is equal to 110 minus 5Q. So now we have our demand curve. So we have profit now in terms of Q. So we can have 110 minus 5Q times Q minus our total cost. So we have 100 minus plus 10Q plus Q squared. So let's find our profit maximizing quantity. So d pi dq is going to be equal to 110 minus 10Q minus 10Q plus 2Q. Sorry, this is just going to be 10. And that's going to be equal to 0. So now we have 100 is equal to 8Q. So for us, we're going to find out that I made a mistake. So let's erase this. Made a mistake in my first derivative. Let's do it again. So we now have 110 minus 10Q minus 10 minus 2Q is equal to 0. So we have 100 is equal to again, another mistake. I apologize. So what I am doing is now making our total cost curve correct so that we have 100 minus 10Q plus Q squared. So now when we solve for our first derivative and set it equal to 0, so d pi dq equaling 0, we have 110 minus 10Q plus 10 minus 2Q is equal to 0. So now we can solve so that we have 120 is equal to 12Q, so that we have Q is equal to 10. Aha. Okay. So now we have Q is equal to 10. That's great. Now what we could do is solve for price. And in order to do that, what we're going to do is take our quantity and plug it back into our price equation. So when we do that, we're going to look at our price equation. So we have quantity is equal to 22 minus P over 5. So we had price in terms of Q is equal to essentially 110 minus 5 Q, so that we have P is equal to evaluated our profit maximizing quantity is going to be equal to 110 minus 5 times 10. So we have essentially a price of 60. Great. So now we have prices and quantity for ourselves. And so I'm going to start kind of building our picture that we need. So we're going to have a downward sloping demand curve. So we have P and Q on this axis. And so I know that when Q is 0, that our intercept is going to be 110. And so now I can build a marginal revenue curve. So this is my marginal revenue curve, and I know it has to be below demand. And so now I can create a marginal cost curve. And so I know marginal cost being that first derivative of our total cost is essentially going to be minus 10 plus Q. So we know that it's going to look something like this, which is fine. But now we have a marginal revenue is equal to marginal cost. And so what we do is we found that this Q is going to be equal to 10, and the price is going to be 60. So now this area is going to be our consumer surplus. So consumer surplus is equal to 1/2 the length of the legs, so 110 minus 60 times 10. So we have consumer surplus is 1/2 of 50 times 10, so that we get 250 is equal to our consumer surplus. So how much economic profit is this monopoly earning? Well, let's put it back into our equation. So we know that profit is going to be P times Q. So we had essentially 10 times 60 subtracted from total cost, where our total cost is going to be 100 minus 10 times 10 plus 10 squared. So we have profit is equal to 60 minus 100 plus 100 minus 100. So that we have profit is equal to negative 40. Okay? So now we look to part C. Given your answer to part A, what, if anything, can you say about the redistribution of income from consumer to the producer? We could say that it was positive, essentially. We know this had to be true in some way, because we know that our profit maximizing level for perfectly competitive firm would be, the price would be much lower and the quantity would be higher. So part D then kind of asks us to answer that kind of same question. Suppose that the government regulators require the monopolists to set the selling price at the long run perfectly competitive rate. At this price, what is consumer surplus? So essentially now what we're doing is trying to find this point. Right? We're trying to find this intersection. So what we're going to do is set marginal cost essentially equal to demand, not marginal revenue. So our demand curve is essentially, we have P is equal to 110 minus 5Q. And so what we know is that our marginal cost is equal to minus 10 plus 2Q. So what we could do here is set these equal to each other. So we have 110 minus 5Q is equal to minus 10 plus 2Q. So we can solve. So we have 120 is equal to 7Q. And so what we could do is solve for this now. So we have 120 divided by 7. So now what we get is 17.14 is equal to Q. Sorry again, I realized I made a couple mistakes here as I was doing the problem. So I want to go back to the previous problem about the profit maximization, at what point that would be. I realized that I forgot a 0 here. So this needs to be 600, minus 100, plus 100, minus 100. So that profit's not negative 40, but profits then become 500, which makes a bit more sense to me now. And then the second thing that I want to do is reevaluate the way that we're completing this problem. So instead of the socially optimal level, the problem actually asks for that long-run competitive equilibrium price. So what I need to be doing here, and what we need to be doing, is looking at that minimum average total cost. So that's what I essentially need to be finding is that I need total cost is equal to divided by Q is equal to average total cost. So we have 100 divided by Q minus 10 plus Q. So that when I solve the first derivative and set equal to 0, I get negative 100 divided by Q squared plus 1. And so we solve for this. So I get Q squared is equal to 99. I'm sorry. It's equal to 100. So that Q is equal to 10. I will get it eventually. So we have Q squared, Q star is equal to 10. That's great. So now we have a output level for us that's essentially going to be at that long run perfectly competitive equilibrium. So what is that in terms of prices? So the ATC evaluated at Q star is going to be 100 divided by 10 minus 10 plus 10. So that we have the ATC at Q star is equal to 10. So now we have, at a price of 10 and a quantity of 10, what is essentially the consumer surplus that we're going to be able to find here. So we need to think about what that picture is going to say. So we can start developing this. So again, now we have demand curve. So we have essentially 110. And so what we've just found is we essentially have a marginal cost curve, something like this. So we have 10. And then essentially what we did is set equal to marginal revenue so that we found this to be true. So we have 10 here. So what we need to now do is look at what this point is going to be at 10. So let's take 10 and plug that back into our demand curve so that we have Q is equal to 22 minus 10 over 5. So we have Q is equal to 20. So this is going to be our 20. So now what we could do is look at the big consumer surplus. So we have consumer surplus for perfectly competitive firms is equal to 1/2 times 110 minus 10 times 20. So that we have 50 times 20, or we have 1,000. So the consumer surplus under the perfectly competitive umbrella is 1,000. So what do we want to know now is deadweight loss. So deadweight loss is going to be calculated as kind of that area that we weren't collecting. So what we know is we are going to have a restricted amount of quantity. So we can kind of draw this picture against one more time to understand what it is. So we have P and Q. So we have 110. So we have this being 20. Now what we could do is draw in our marginal revenue. And from marginal revenue, we're going to be able to plug in our quantity and our price that the monopolist is charging. So we have marginal revenue. We know this is 10. We know this is 10. We knew that this then had to be 60. So our deadweight loss is going to be this area right in here. And it's shown in our solutions here as well. So how do we get that? We know that deadweight loss, or the area that we can construct, is 1/2 the length of our legs, so which is 60 minus 10 times 20 minus 10. So we have 1/2 times 50 times 10, so that we have 250. So the size of our deadweight loss is 250. Good, so that was a fairly long problem. Sorry for some of the errors there, but it's a very good one. Something that we're definitely going to have to work through either on a quiz or in a homework. And the last little slides that we have here then are talking a little bit about what we could use this analysis for, one being natural monopoly. And we've expressed what a natural monopoly is, but what we understand or what we notice is that there's really nothing new in terms of the math that we're doing here. We understand that this long-run average total cost curve is downward sloping. We could try and find points on this long-run average total cost curve. But really, its design is what's important to us, is that's what's telling us we have a natural monopoly. It's because of these economies of scale, we assume a monopoly should exist in this industry. And then the last bit kind of moves us into the direction of monopolistically competitive firms and oligopolies, and that is the idea of collusion. So we talk about collusion as two or more firms acting as a single producer to choose quantity or price. So essentially what they're doing is making sure that they're acting as if there was only one producer in the industry. And as a result, they get to split industry profits, the monopoly profits. They would only do this if that splitting of that monopoly profit is going to be bigger than if they were to compete directly against another firm or many other firms. So that's the next part of analyzing this. We realize that collusion is definitely illegal in the United States and most of the world, but not always the case. So we can actually see in practice a few collusive agreements happening. Consumers are harmed in the exact same way as if there was just a sole producer for the industry. And that is, again, because these producers are acting as a sole monopolist. Firms must decide then how to distribute the monopoly profits, and I think that's a really interesting point to stop on, and then we'll pick up in subsequent lectures. And that is it for Lecture 7 here.